So I had to pause that last video, and I noticed that the answer wasn't visible on the whiteboard. The answer, the second part, the change in potential energy on the first problem was minus 9.8 times 10 to the 10th joules. Okay, now we're going to do problem number 2. And I went ahead and wrote the variables that we know on the whiteboard. What we're trying to solve for is the change in potential energy. In order to solve for the change in potential energy, we need to know the change in voltage. We already know Q, that's the small q. It tells us in the problem what that is. It also tells us what the fixed charge is and the two radiuses. So radius 1 and radius 2, the object is going to be moving away from the fixed charge. What is the change in potential energy when that happens? Remember also to always start with coulombs and meters. If your problem doesn't give you that, you have to convert. You always have to use meters and coulombs. Okay, so what we need to do is find the change in potential, electric potential, which is V, as it goes from this radius to that one. This is the equation for that. V equals KQ divided by R. So I'm just going to write these down. K being Coulomb's constant, and I'm not going to write all the units for that, just because of space. It gets really cluttered, but you should not be leaving those out because you should have plenty of paper to write on. So 9 times 10 to the 9 newtons times meters per coulomb. And then the capital Q is the fixed charge. Oops, wrong one. That was from problem 1. This one is 7.4 times 10 to the minus 6 coulomb. And the initial radius is 0.13 meters. Answer is 5.1 times 10 to the 5th voltage. So pause your video at these points so you can work the problem yourself. We're going to do the same thing for the final. It's going to be the same K value for K, always for K, same value for Q. The only thing that's going to change is R. So this, R2. So this time use 0.85 meters in that same equation to see what you get for the final voltage, final electric potential. Okay, there is the final. Now we're going to find delta V. Remember, the change is always the final minus the initial. So subtract that from that. Subtract that minus that, and you will get, it's negative because the final is larger than the one it started with. Larger than what it started with. Or I'm not sure what I just said. I probably just messed you up. But if you take that number minus that number, you're going to get a negative value. Okay, then the only other thing we need to do is put that in, use Q, the charge that's put in that field, to find the change in potential energy. It's going to be a negative number. The change in volt is negative. So there's your answer. Okay, so that's the answer for number 2.